Let's see if it works. Let's see if the stream starts. It says it's on. It says it's on. And yes, I do have a green light. So, hello and welcome to all the new coders that are watching this and all the coders who are persevering in their web development journey. Today, we're going to be talking about overweight JavaScript. Hold on just a second. Sorry about that. Yes, today we're going to be talking about overweight JavaScript and how we can minify and put our JavaScript down on a diet. I'm picking on JavaScript, however, there's all sorts of different types of, well, in any kind of programming language, in any kind of web development discipline, you can always reduce and condense down your solution and therefore have a better product to give to your client or your customer, be it on the front end or the back end. But today I'm going to just pick on JavaScript and what we can do as JavaScript developers to crunch down our JavaScript application, make it a little lighter, a little bit more simpler, to not only maintain and manage going forward, but also how that can alter the behavior, but alter the interaction to the front end, how the user journey can benefit from having a lightweight code rather than humongous amounts of assets that have to be pulled in and downloaded and using different CDNs and all of that. So we're going to be talking about all of that stuff. But first, though, I just want to welcome everybody who's subscribed recently to the channel, and of course everybody who has already subscribed. Thank you ever so much. The channel has now hit 4,700 plus subscribers, which is just amazing. So thank you ever so much for subscribing here as well as on Twitter and Instagram. For anyone who is watching this who hasn't subscribed, please do so, because this channel is all about teaching code and web development. I hope that you'll be able to learn and progress your skills in that. We have tutorials every week. We have a live stream like this every Wednesday where I talk about a particular topic, today being overweight JavaScript. And then on a Friday, we also have another discussion too, although that's pre-recorded. So hopefully you'll be able to come away from this channel learning something. And also I learn loads from this channel too. You know, all the questions that I get, it helps. It's a two-way street, you know. So hello to everybody new and old. I hope you are all well. I appreciate today is Halloween, so unfortunately I don't, well, I might look scary, but I'm certainly not in a Halloween dress. There is an awful lot of candy downstairs that I have been told not to eat, although I have been eating quite a few. So hopefully I'll end up with some candy later this evening, maybe in the later part of this week. Anyway, whatever. So JavaScript and overweightness. Where should I start? Well, we seem to be constantly battling between having lots and lots of hardware improvements, lots of software improvements, lots of new ideas, and then lots of consumer demand upon those ideas. So take, for example, one thing that is kind of coming into a trend right now, and that is video on the homepage. So your whole homepage being a video that you can play in the background, and it's got no sound, but it kind of shows you, perhaps this is like, for example, a video demonstrating a holiday home or a holiday or some sort of product, that kind of thing, and it's very nicely sort of videographed, and it's showing you all this kind of slow motion in the background, and then the words kind of animating and all of this stuff. It looks fantastic, completely terrible for SEO, sure, but it draws the eye. It draws the eye in. It's very graphical. It's very art. However, it is humongously intensive on the bandwidth. And the school of thought of let's just, consume all of the bandwidth that is on offer, and bandwidth is one of these things that is just constantly going to improve and get better and better and better. That there is no need to worry about having these kind of things on the front end. There's also no kind of worry of having all sorts of different frameworks and libraries being plugged in left, right, and center. And we unfortunately get into this position where instead of looking at the places that we can reduce our file size in the kilobytes or even bytes, we're actually looking upon where we can reduce them in the megabytes. And it's a bit of a horrible place because you end up having bloat for bloat's sake. And it's not technically strictly our fault. Because perhaps we aren't aware of all the complexities involved in building those frameworks, in having those libraries. It is something though that I think that we should, as developers, be aware of. And I'll be talking about the applications and the projects that you can look at to analyze your own code base to discover where the fat is and see if there's anything that you can replace it with. I'm also going to be talking today about increasing the size of your application to decrease the size of your application later on. And I'll be talking about that later in this video. But it seems to me that the front end, there's two schools of thought here. There's one school of thought that will just push the boundaries of your JavaScript by having all of these fantastic, lovely frameworks and libraries without any regard to the size of your application. I guess it's up to the developer to decide what frameworks and libraries to use. And then there's another school of thought that is, let's try and condense everything down to the smallest, simplistic, minimalistic thing that we can possibly have. And not only is that going to be best for the end user using the application, but it's also going to be great for the developer maintaining that application going forward. Why would it be great for the end user? Well, because when you have a smaller application running on the client, that means that it runs faster. I do a lot of back-end stuff, right? So we do a lot of monitoring on the back-end code to see how fast and speedy things are, like API requests, and we put in caching layers and all of this stuff like memcache to cache all the responses, and we use crazy technologies to flush that cache and to prevent stale cache and all of that good stuff. But we as back-end developers can't really have too much say in what the front end is actually doing in terms of how it's rendering all the information we pull it down. And there has been times where I have had discussions with both front end and back end developers, and there has been an argument as to where the speed increases should be. Should they be in the front end? Should they be in the back end? Should they be in the database? Personally, I'm a full stack developer, so I kind of take the view of there is speed improvements to be had at every possible level, but obviously go and find where the bottlenecks are and focus on those first before actually minimizing other bits and pieces. Because obviously when you do minimize things, you are changing, and when you're minimizing legacy stuff, you're actually changing quite a lot. It's quite a drastic change, because if you want to replace one library with a lighter library, then that's quite a core change to make. Whereas if it was an API response and you were just caching that API response, well, it's going to be the same API response regardless of whether it's been cached or not. The only danger there is having stale cache. And obviously with the MySQL, maybe it could be structured slightly better, but the response coming back could be the same response as it's always been. It just be the schema of the database could be slightly configured slightly better. It could have better indexing, better foreign keys, better constraints, and all of that other good stuff. So there's so many different ways of making something smaller and lighter and improving. Now, the thing is the biggest misconception is that making something smaller and lighter is actually improving it, because actually, in fact, making things smaller and lighter might complicate it as well, because if you're having to remove a library or a framework that does a lot of stuff that you wanted to do, but you're only using, say, 40% of that, and then you just make the decision of, let's go and change that, remove that to something else, and then later on you discover that the things that you've just removed are the things that you kind of need right now. So you do end up playing this sort of game of predictions. What is the application going to be doing in 3 months' time, a year's time, 2 years' time, when I actually get to the point of removing this library or this framework? And talking about libraries and talking about frameworks, there are so many things that JavaScript developers can do these days, and HTML and CSS, they can do, that perhaps frameworks, we were relying on frameworks to do, say, a few years ago, or even today. I mean, still today, legacy code is the biggest piece of code out there, right? I mean, every project that I've touched upon has some horrible mess somewhere that some developer has built years ago, and there's been no need to look at it. And then I go and look at it, and it's like, yeah, if we replace this with this, then it would be more efficient, more better. But then I discover that there's no unit tests, no documentation. But anyway, that's another story. So, completely losing my thread here. So changing frameworks, changing libraries is a big thing, a big step, a big bold step. And there is a lot of things that JavaScript and CSS can do, like I mentioned, that just you would have had to have relied on things like jQuery. You would have to rely on things like Bootstrap. You would have to rely on other very bulky sort of frameworks, libraries, like even Modernizer, that puts in lots of polyfills and alters different things to behave as they should be, but for older browsers. So that is in itself another consideration, is what kind of browsers are you supporting? Can you get away with reducing the amount of browser compatibility issues that you've got by just saying, you know what, I'm no longer going to be supporting all of these old browsers, all of these old clients, all of these old devices that I'm using here. I do a lot of mobile apps, and one of the controversial things is how many devices does this need to go on, this application go on. Android is terrible for having fragmentation in the device world, because you have devices of all different shapes and sizes, whereas when you've got iPhone, you are working with a defined set of sizes. Those sizes aren't going to be changing significantly in years to come. Yes, they're slowly getting bigger, but they're not getting any crazy sizes like perhaps the Android tablets are. So when building applications for mobile phones in JavaScript, that is a consideration as to the screen real estate that is on offer. And I guess that's more to do with the design and the look and feel of things, but obviously the JavaScript that I'm writing to build those mobile apps has to conform to those kind of things as well. And also doing the checks for what device it is, and so on and so forth. So JavaScript touches all sorts of different things. Okay, it touches all sorts of different clients and devices, more so than perhaps PHP and Python. These things, PHP and Python and Ruby and C, they work on the server, right? And so they don't care how it's going to be displayed, how it's actually going to be rendered to the page. So you want to be so it has no regard as to how quickly it's going to be on the front end. Obviously, there are things that you can do to speed up that particular request. Maybe if you compress that request, fine. But we're talking about JavaScript today, and how JavaScript can become incredibly bloated. And there is one thing that really does bloat the front end, and it's bloated the front end far more than anything else in the past 5 years. That is the node, the underscore modules, the node underscore modules folder. That is huge. Go and check it out. Just check out the file size of all of that. It is incredibly large in a project that you probably think is extremely small and lightweight. And we get into this sort of false misconception of only just deploying things like our package.json file and not considering what's in that modules folder. Because we're only committing that one little single file, we forget what the repercussions of that massive file has. And when you go and build and deploy the application, you're left with this ginormous weight on your application of all of the things that you've had to download because your Webpack file requires all of these dependencies and all of their dependencies and so on and so forth. Because of course, you're not only downloading the dependencies that are outlined in the actual JSON file, but you're also downloading all of the stuff for those dependencies too. So you might get if you haven't looked at your node_modules folder, you might get a bit of a shock at actually the size of that. And you have to take that into consideration, especially when we're talking about progressive web apps, because that is going to be downloaded to the device, to the application, right? So so your website is becoming huge in terms of file size because you're having to carry all of that weight with you, and it just gets bloated. It just gets big and big and big, and bloat often means slowness to load. I mean, when we start talking about little apps that just display blogs in progressive web apps, which are more than perhaps 20-30 megabytes, then that's insane. But that is the world that we're living in, unfortunately. So I'm just going to grab a drink, and then we're going to be talking about how one can actually go about putting everything on a diet and analyzing the JavaScript and seeing where the bottlenecks are and the pinch points. Just bear with me just a second. So on my other machine here, I have a list. Close that one down. Okay, so the most simplest thing you can do is to take a look at your web development toolbar, be it in Chrome or be it in Firefox. I believe there's even one in Safari, and take a look at the network tab or the resources tab or whatever it's called, and then refresh the page and see the amount of requests and how those requests are being processed and what requests are having to wait for the other requests to work. Then you'll be able to perhaps narrow down a particular bottleneck. Maybe, and I know this isn't strictly JavaScript, but maybe there is a load of image files that you're having to download, and maybe those image files are ginormous in terms of dimension, therefore file size, but your front-end application is actually forcing that image to be smaller in perhaps CSS. Maybe you are using all sorts of different little icons individually and therefore requesting those individually. Maybe what you need is an image sprite, a sprite being a single image, and then all of those little images are stored on that sprite by a couple of pixels apart from each other, and then you use CSS to target which particular image on that sprite is what you're going to be using the icon. Therefore, you can just cache that resource. But it's focusing on the JavaScript. We need to look at how the JavaScript is actually processing. So what I recommend you do is you create some JavaScript functional tests that can run through your application and just sort of time the application and see how the user or sort of mimic the behavior of a user and see where the bottlenecks are. Why are websites in 2018 not loading until everything else loads? Why do there's loads of websites that I've been on recently where the content just doesn't display. You just get a little circular loading sort of thing, the old Ajax spinner, and then suddenly everything appears. How about doing lazy loading? How about looking at the loading from perhaps the top down first. So getting everything in the top section, and then as the user scrolls down, then you start pulling in stuff dynamically. JavaScript is incredibly intelligent, especially when we talk about service workers, Ajax, and all of that kind of networky type stuff, and knowing exactly where the user is on the application. We don't have to pull in all of the bits and pieces, like, you know, all the many stuff, like all the results and the resources, before the user actually gets to that point on the page. And also, maybe we want to be intelligent and have some level of calling the back end to get the next set of results before the user actually clicks on the next button. So instead of just getting the first page of results, maybe we get the first page of results, and then in the background we do an Ajax call to get the second page of results, and therefore when the user hits page 2, it's instantly there. So there are lots of clever ways that we can use to alter the way those network resources are handled and those calls are being processed. But let's just focus now on the actual node modules folder and actually see what packages we're actually using. One thing that, one piece of software, I guess you would call it, something that it has been fantastic for me recently, is this website called Bundlephobia. I'll put links in the description down below. Bundlephobia is a website that you can put in the package name and its version, if you wish, and it will tell you how big that package is. It will also tell you similar packages and their sizes in percentage to the package that you are using. So unfortunately, I've got this running on my other machine here. But essentially, you put in, I just did this on a package called Moment. If you're a JavaScript developer and you've worked with dates and times, you've probably worked with Moment. It just helps you create or alter dates using JavaScript, because JavaScript is inherently bad at dates, I find anyway. So Moment is a nice little library that you can use to handle those kind of things, handle UTCs, timestamps, handle different formats of dates. It's really, really nice. I've actually used it in some mobile applications before. However, it is 227.k in its minified form, and its download time in its unminified form is 1.28 seconds. So it's actually quite a heavyweight thing. And if you scroll down on this, you'll be able to see similar packages. One similar package is day.js. The other one is date-fun, so date function. Both of these are over 90% smaller than Moment. And this is where you have to go, well, perhaps these libraries do not have all the things that I need that Moment offers, and so you do need to do a level of analysis to see those limitations, if there are any. But 90% smaller is huge to actually put your application on a diet. So do check out Bundlephobia. I'll put links in the description below, in the show notes, after the video is streamed. There's another one here called Luxon as well. I've never heard of that one, to be honest. That's pretty cool. It also allows you to scan your package.json file. So you upload that and it'll scan that file and it'll tell you what packages that you're actually currently running, and it will give you the similar packages and their sizes too, which is fantastic. The other tool that I want to talk about is Webpack Visualizer. Webpack Visualizer, it's chrisbateman.github.io. Again, I'll put the links in the show notes after this. And yeah, it gives you a nice visualization of your application, of your Webpack JSON file, and it will tell you in sort of a very visual way at what are the biggest parts of your packages. maybe it's the framework, maybe it's certain libraries, and you can actually go quite in depth and actually discover the sizes of each of your packages and each of your dependencies. And then from there, perhaps you can look at different alternatives. It also comes with a plugin, which is Webpack-Visualizer-Plugin. But a point that I would like to make, though, is that when you go ahead and download these plugins, make sure you download these analytical plugins in development mode and not in production. You don't need any of these in production. You are literally making your application bigger by downloading these things. So be cautious when you go and actually analyze your application locally, because you don't want these sort of auditing tools to be out in the wild in production. A, there's a security issue there, and B, you are doing the exact opposite of what you're trying to do and scale down your application, because you're actually adding to it. So these are two really good ways of analyzing your code: Webpack Visualizer and Bundlephobia. I really like Bundlephobia because it's just so obvious that how big your packages are, and it just gives you a easy way of saying, yes, this is an alternative. This is actually 90% smaller, and it'll save time. So one thing I definitely recommend that JavaScript developers do before they even touch this at all is write some good unit tests, maybe some functional tests, just to make sure that you have something that will tell you when you go and change these libraries that something is broken and wrong. Because what you don't want to do is do this kind of change, this alteration, this sort of what do you call it? Plastic surgery, if you will, to make your application smaller and lighter in the dark. You don't want to just assume that everything is correct and working after you've done this. But of course, there's other things that you can focus on as well. It's not just the size of the application, of the actual packages that you're using. It could also be the way in which you're using them. So, for example, you could be not using the right way of doing promises and fetches and Ajax and all of those calls. You could also be using things like service workers to do a lot of this stuff. You could also be harnessing some front-end caching. You could also be harnessing the caching from the back end too, so sort of gzipping that down. And also do check out the Google tools as well for speed tests. There's a fantastic speed test tool for mobile applications. And also do set yourself some limits and some goals and say, look, every page I want to get down to a certain percentage or a certain amount of seconds, and then analyze every single page in your application. Not only every single page, but every single process of that application, and see where your application is slowest, and then perhaps sort of bracket those off into different categories and say, today, this project, we're going to be trying to bring this set of pages down by this amount of milliseconds or this amount of seconds. And then because really, when you start analyzing your code, you'll probably be freaked out by the actual slowness of the whole thing and the size of the whole thing. And so you want to change every single thing. And that really isn't realistic, simply because that you probably have far too much to do, and if you go in there like a bull in a china shop, you'll probably end up breaking stuff. So sort of try and take a look at it with a pragmatic approach and actually see if there is a more of an objective way of reducing things. You might also find that the small little calls that you make are just sort of really slowing down the application. If you're making those small calls a lot, then it's kind of like a death by 1,000 cuts. So like I said at the beginning here, we could perhaps bring down maybe the second page, the third page of results, and cache those in the background, ready for the user to actually do those bits and pieces later on. YouTube here, I mean, YouTube is a fantastic example of where they do that kind of prediction, because when I go and upload a thumbnail, or no, not really a thumbnail, when I go and upload, say, an image for the end screen, it will recommend, if it's a link to a website, it will recommend the images on the website. On the first sort of instance of that, it will recommend, say, three images, and those images are incredibly slow to download. But once they're downloaded and I press next or forward or back or previous, then they're incredibly fast. There's no need to fetch those again because they've already been retrieved. The downside of that, of course, is if I was to go on the website and actually physically change that image and then go back to YouTube and then put in that link again with that image, then the image won't change because it's already cached, it's already been downloaded. So that is a trade-off. So you do have to think about the pros and cons of caching and the pros and cons of reducing the size of your application down, because it's very easy for us as developers to just sort of pretend that we're end users and click about and stuff. But we as developers will never really use our systems in the same way as the actual people who are going to be using our systems in an everyday world. The amount of clients that I've built websites for websites that I won't personally use, because maybe it's a shopping, an e-commerce website for a product that I don't necessarily use on an everyday basis, and therefore I won't use it. However, I'm a developer, and therefore I've developed that website with the assumption of how it would be used, but without having that sort of feedback from an actual real user. I can never really know how the user is actually going to use it. And so you could end up speeding parts of your website up which really aren't being used. And so one thing I would suggest is perhaps do some sort of market research if you've got a massive website that you're looking after, because you want to ensure that the things that you are working on are prioritized correctly. And sometimes there is a trade-off. Sometimes you might analyze all of the pages and the loads on those pages. You might discover a whole portion of pages that are incredibly slow, and yet they're not used, and then probably not used because they're incredibly slow. And so you might want to take the approach of let's fix some of those, but not all of those because they're not being used. Let's fix the ones that are being used more frequently, and see if we can reduce the size on that, and then perhaps bring in some of those other larger pages to fix, but let's not heavily prioritize those. Otherwise, the thing is, one is just chasing numbers rather than chasing the actual requirements and needs of the application. So yes, it's all well and good to have a really slick website that runs incredibly fast, but there's no point in putting in huge amounts of effort to make your website incredibly fast when nobody is necessarily looking at that website, and you could have been putting your effort in to creating new features to get people onto the website. So it's a trade-off. It's a trade-off between creating features and altering existing code. And a point that I would like to make in the freelance world is that when one analyzes code that is already in existence, it becomes a challenge to recommend improvements against features. And I guess this isn't just for freelance; it's also for the other for full-time developers as well. But this is where metrics really helps. So if you have the ability to audit and analyze your code anyway, if you have the ability to go to those kind of meetings with a report and say, these pages are really slow, and this is perhaps the Google Analytics that tie up to those pages. And so if we were to reduce the file sizes of these things, reduce the frameworks, do a little bit of tinkering, add some caching in, hopefully the Google Analytics will show that more people can actually get to this stuff because perhaps the servers aren't as overloaded as they are right now. I mean, recently I've been doing a big project on scaling down, or I should say not scaling down because it's scaling up, I guess, but speeding up a whole massive legacy application. And the thought process to that is that the quicker it becomes, the more more requests we can handle. And so it's not necessarily a goal of let's get the pages down and really quickly. It is how many requests can the API support. And there's no point in having a super quick, fast API if the front end is just so slow at actually delivering everything that the API has actually just processed and given. So it is a bit of a battle between the two sort of ends of the spectrum, if you will. But at the end of the day, if the application is quicker to use, then you're going to find higher sales because people will be able to get to the checkout quicker. You'll be able to improve that better as well, especially if you're using service workers and you're actually pumping things in as they are happening, rather than this is a static application that I'm giving you, that kind of thing. And also when you start looking at these packages and actually looking upon them as a way of do I really need X? Do I really need Y? Is this actually helping me out? Then you actually get a better understanding of what your application is actually doing and requires. And there's all sorts of edge cases that I've found when I've actually analyzed my node modules folder. I've actually analyzed my my packages, because there are things that I just never thought that I had as a dependency. And also there are lots of things that unfortunately I have discovered that pose security risks. You'll never know that until you actually do any kind of auditing and analysis on your modules. Bear with me just a second. So I mentioned earlier about adding things to your application, making your application bigger to make your application smaller in the future. And what I was sort of hinting at there is polyfills. Polyfills is a way of adding glue into your application that allows older browsers to behave in the similar way as the features that you're trying to implement right now. So recently what I've done this week, in fact, is I needed to put in a pop-up on a web page. And if I was to do this, say 2 years ago, I would have used jQuery UI to do this. So I would have used jQuery UI to bring up a dialog with perhaps a modal window. Well, part of me was thinking, I know exactly how to do this with jQuery. Just add jQuery and have done. You can get it done in a matter of minutes. But then the part of me that actually won was, hang on a minute, there is a dialog HTML element in HTML5, I think it's 5.2, that has some support, especially for the likes of, I believe, Chrome, but doesn't have and Firefox, but doesn't have support in IE. Right, okay. So let's go and take a look at the polyfills and see if there are any polyfills for this. Yes, there was a polyfill for the dialog. It's called polyfill dialog. Yes, that means that we're going to have to add a package to our package.json file, which will mean that our application is bigger in file size. However, I'm not having to download and force the user to request jQuery. jQuery UI, at least, is actually quite a massive framework. And yes, I know that you can pick and choose the different components of jQuery, but I think that once you start going down that rabbit hole, it becomes a little bit easier for you to be tempted to use jQuery to do other things that perhaps will be supported in the future by standard. And also with jQuery, you end up having to write in jQuery, which means that you become invested in jQuery, which means that you're going to be less likely to change jQuery later on, because you would have to change all sorts of manner of code. So there are lots of things that we as developers have to sort of take a stance on. Do I make the application a little bit bigger now, and perhaps have a lot more sort of polyfilling, a lot more sort of glue code in right now to benefit me in the future? Because as soon as Internet Explorer decides that it's going to be supporting dialogue, then that polyfill can be simply removed, and it's not going to be any more harmful than just removing a single line in the package.json file. Whereas if I was to use jQuery, then not only would I have to change the way the dialogue actually works by removing jQuery and replacing all of those dialogue calls with the HTML5.2 dialogue HTML element, but also I would probably go down the road of using jQuery and all sorts of other things in the actual application. And so at the time of removing jQuery, I would be hesitant to do so simply because I would be more invested in that. And this is sort of an example of the decision process of a JavaScript developer, of a typical JavaScript developer who gets a requirement and perhaps doesn't have the knowledge that there is alternatives out there, but B, doesn't have enough time, or has been given enough time to implement those kind of things. And also as a freelancer, if I was given a project that had jQuery in it, then I would still probably use the dialogue in HTML with the knowledge that I've got now. I didn't know that the dialogue HTML element was available until about 2 weeks ago. So I had to discover that. So there is a portion of time that a developer has to do in order to learn the new technologies that are coming through. And again, that takes up time. And if you know that there is a framework that you can, a library such as jQuery UI that you could use to get that to work quickly, and if you are concerned about the time in which things take, then you would go out of your way to do that, to take that that alternative rather than to do the research. I think. I mean, this is just my personal view, but you can kind of see how you get sort of, you get invested in those kind of decisions. Before you know it, your whole application is written in jQuery, and you can't change those small little things very, very quickly. And so, yes, you might end up with a dozen or so different polyfills in your application. But if you are constantly doing an audit on not only all the things that you have in your nodes.modules folder, but also an audit of what is available to me right now as a developer, what are all the things that are coming in CSS and JavaScript and HTML, if you keep yourself updated with that, then you'll find that you'll be removing those polyfills as new things come in. And by having that series of review, you become better at understanding the application as a whole. The node.json folder, the node_modules folder, yes, we do a git ignore on that, but we ourselves as developers surely should not ignore that folder, because that folder is incredibly large. Bear with me. Now, I'm not saying that jQuery is dead. I'm not saying that jQuery is something that you should avoid, but I am saying that there are alternatives out there. Not everyone can use dialog, the dialog HTML element that I was discussing. There are some cases that you are forced to use those kind of frameworks, those kind of libraries. Perhaps it's already been decided for you, and you just can't move away from that. Perhaps, for example, you have to run a certain legacy browser for some weird reason. You just have to support it, and therefore you're forced to use the old ways of doing things, the old ways of creating dialogues, and bits and pieces like that. So this is where I'm going to throw it off to you guys, because we've moved on to 45 minutes now, and I want to see what you guys think. Is there any ways that you as developers have reduced your code? I'll be interested to hear from you guys. I'll be interested to see if you've used any of these tools that I've mentioned, the Bundlephobia and the Webpack visualizer, the networks tab in your web development toolbar. If you've analyzed your nodes.modules folder, and if after this talk you will do so and actually discover what it is that your application is using. And also, if you've got any thoughts on what is going to happen in the future, perhaps with progressive web apps, with all of these kind of things. So I'll be interested to hear your guys' thoughts. But anyway, thank you ever so much for watching, everyone, and I'll see you again soon. Cheers. Bye.